opportunity to share what we did actually for the last 2 months with these ginkgo nuts. So I will present about also the image processing of ginkgo nuts, but a little bit different with the one that already discussed by Zoe last week. This is the ginkgo tree that we can find easily here in Japan, including in the campus area. Actually, if we talk about the ginkgo tree, there are 2 types, male and female. The one that used for greenery may be the male one, so we never see the fruits. Yeah. If we plant the female one, we'll have many fruits. The male one only produce or grow a nice leaves, so they are used only for greenery. This is after if we remove the flesh of the fruit, we will have a very hard seed. Yeah. Here you can see the seed after, of course, it's already dry, and inside the seed you have very like soybean, young soybean or edamame in Japan. The natural green is almost transparent, light green, transparent, and it will turn into a bit yellow after exposed in the open air. So I guess this is because of the oxidation by oxygen. The actual color is like this. This is very hard seed, so if you want to open, you cannot crack with your hand. So you may need maybe some tool like this, very hard. And some people already learn about this seed. There is actually 2 tips, but they have a different level in the hardness. Yeah, I can say the hard and the hardest because all is very hard. Yeah, but one is weaker than others. This is very clear when we compare with the pistachio nuts. Yeah, Japanese people or Chinese people sometimes call this happy nuts because it's always smiling. Yeah. This is the weaker point. This is the hard point. And same like this. If it is grow, naturally it will open in one way, and then the roots go out always from the tips. Yeah, that's why we want to detect the tip. This is the picture I got from Zoe. Yeah, from he said top view and back view. Give number here 1 and 2, and if we see from the side, and people want to open or crack, they can use some tool like this, so it will open like this. Yeah. This is the hardest one. This is the weaker point. So we have to know this tip so we can place the nuts in the right way. And this is also Zoe talked already about this. He used a linearly square method to differentiate between front and back, and actually he analyzed every dot in this line. So if we take a look more closer to this part, every dot has a distance to the regression line. So Zoe analyzed like this, and we can call it this statistical based method because it analyzes every dot as a population of the dot. But today I will talk about different way, morphological operation, a different approach for this. Sorry. the term of morphology is to analyze or to get a description of the properties of shape and structure of any object. And in the image processing, it's become the areas on the image. And the operation is very much the same with mathematical, because image is actually the array of two-dimension array, the data in the two-dimension array. So we can treat image as a two-dimension data, and we can do some operation on that data. The famous, and maybe you heard many times about the morphological binary morphology, are erosion, dilation, opening and closing. This is very common to use in shape analysis. In this method, I capture we capture the image from the top view, not from the side or from the front, like the one that already introduced by Zoe. What is the advantages of the top view image acquisition here? I can say that easy to arrange the hardware, because you can put the camera on top of the system. We can capture multiple nodes in one frame, and no need to arrange node before capturing. So once we detect the tips, then we can arrange the nuts using any other tools. Like this is the simple manipulator to do this. That's the thing that the man from the company wants to do with these nuts. And this is the image camera used for the acquisition. Actually, this is arranged by Mahira, and so I just borrowed the image. I didn't do it myself. So you can see here, I will need only from the front light. I don't need the backlight. But one image is because of the nut is wet, so it's not good. It's not very good to analyze. So I replace with the backlight. This is the three nuts: Tokuro, Kyujyu, and Ginkgo. You can see here from the top view, and this one that I said not good, so I replaced it with backlight. But not it doesn't matter, because I don't need the color or something. I just need the shape this time. This is the software I use to develop the program. Yeah, this is actually the Microsoft Visual C#. The Express edition is free. You can download from the internet. And this is my program developed by this. And the operation is I resize the image into smaller one to faster analysis, then binarization, opening by standard size 3x3, closing, and tip detection is to locate the part of the nut. Tip part of the nut to the finding centroid, then to farthest point from the centroid in the opposite direction, and then calculation small area of the 2 points, and compare each other to determine which one is the part. This is the illustration. Find the centroid here, and we find the two direction in the opposite, farthest point in the opposite direction. Then make some small area here, and then calculate the overlap area and compare, because the left one is smaller than the other, so left one must be the tips. That's the simple idea how to recognize the tip part. This is the result for the Ginkgo, the long type. No problem at all with the Ginkgo. All of the 20 images we have recognized very well here. For Tokuro and Kyujyu, not very good. Some are still missing. And we take a look at the why we have problem with Tokuro and Kyujyu. Yeah. I realized that Tokuro or Kyujyu sometimes they have two tips in the back side. So this can mislead to recognize as the one we want to recognize. So take a look at this part. Will be like this, the zoom. So this is recognized wrongly because it has two tips, so this part is not good. I expect this yellow line, but that a different. So this area becomes smaller than this. So I use another structuring element for the morphological analysis. This is 20 by 20 to fill the gaps and holes inside the binary image, and this is the 45 by 45 to smooth the edge to make recovery of that problem. This is the example of the operation. Here you can see a little bit change. This is this area is filled a little bit, but not so good. You can see very clear here. Also inside, the number is also erased here. But I just want to say that we have small effect here, but we don't experience any effect on the other side. So that's the work of the filter we want to apply, so we can fix some problem and let the other not affected. And then this operation by 45 by 45 structuring element also makes some a little bit different, and finally it can produce the more smoother line here, like the yellow line I saw you before. Then after this operation, this again didn't affect the other side, the other tip, the process. So by this process, we can see that it changed from wrong tips to the right one, because of now the form already fixed, the shape already changed, so it produces also different. And this is the improvement, the Tokuro, a little bit improvement. Kyujyu, all can be recognized by this method. As a conclusion, I can say that the algorithm is effective for the Ginkgo type or the long type Ginkgo nuts. For Tokuro, we need additional process to obtain the good result, and for Kyujyu, still needs some improvement. But I can say here that it's too early to make some conclusion because we have only few images. If we work in large number of images, maybe we can find another variation. Maybe we can face another problem, especially if the sample, the shape is not very the same, or some variation in shape. So this is not right time to have a conclusion. Yes, to see how the algorithm works in this. Possible improvement is maybe can use the a combination of the small area and the distance. Right now the distance D1 and D2 is not used, only the area. Maybe by combination I can expect some improvement here. The other one is maybe the comparison between the green area and the yellow area in every side. So this may be also, I don't know, but it's maybe we can try to see like that. And of course we can check also the image size, the structuring element size. Different size will give different result, and so on. And I think that's all my presentation. Thank you very much for your attention. Thank you. Yeah.
I don't quite follow you when you talk about the smooth edge. The problem that there's two tips on the stack. Can you explain that again?
Which one?
Maybe this one. You have two tips on the back side.
Oh,
Yeah.
this one. Yeah, this is tips and this is tip. Yeah. The idea is very simple. If you have very seed like this, and you draw the line, this is alpha, this is maybe beta, so alpha always smaller than beta. Because this is smaller, when we put a circle here with the same so we have area here and we have also area here. So logically this area A1, A2, A1 will always smaller than A2. That's the way it's the algorithm works.
Yes, but in this situation, your algorithm fails.
In this situation failed because it has two tips here.
Yeah. And then you use other process to smooth the teeth.
Yeah. Here I use this to fill the small gaps and hole. Small gap, I mean here, small gap. Hole is here, but hole is not so important here. So this, after processing by this filter, become like this, and then process again with this to become like this. That's why in the second run it can recognize the algorithm work. This is smaller than this.
So your filter will not affect the front
This side? No.
Front tips.
No.
Just only affect
Only the abnormal form. Only the abnormal shape will be affected by the filter. That's actually the purpose of the morphological analysis. We have to choose the correct structuring element, the correct form of the structuring element to change the image into the one that we want to.
Anything else? The first question is, how did you get the two tips position?
Two tips. This is very simple. First, I found the centroid, and then check one point very farthest to the centroid, and the other one is farthest one from the opposite direction. So I got two tips.
Oh, these tips. It's a round shape.
Almost round, but it's always find the right way. Almost round, but not really round. It will have some problem with really round. So every point is same distance to the centroid.
How about the three tips? I mean the front side one tip and the back side two tips. Which?
Yeah, that's also possible. That's also possible, but it's not so easy to do that because this is not really the opposite direction. The third point is in what direction, you don't know. It can be left or right.
Okay.
when you are looking for your furthest tips, do you do them independently, or do you do the furthest one first and then 180 degrees to the next?
That can be done, but we have to do some mathematical computation. I do more simple. I found one and then use this as a base, and then find another, the farthest point. This is the base used for the first trying. This is as a base, but after that base is here.
So the next one cannot be close to the first one you found. It has to be.
Yeah, if I use this as a base, the second one may be here. So I use this as a base, and it will go to this point as the farthest one. Very simple.
Anyone else? Okay, thank you very much for your contribution.